Hey there, welcome back to another video from the Math Doc. This time we are going to discuss equations, and this video will be incredibly basic. I want to review what an equation actually is and what can we do to an equation, or not even what we can do with an equation, but what we can do to it, so that once we get into linear equations and other subjects, these basic concepts will be sitting well, and you'll have a video you can go back to for reminders. So what is an equation? Well, the word equation comes from the word equal, right? Equal is sort of in the word equation, and what it means is that there's two sides to an equation, and they are equal. And so when we're really young and we're just starting with math, we may be counting balls or balloons and books, and we can equate the number of objects here, right? We have 3 books equals 3 balloons. Here we have 3 balls, and so that equals 3, and here we have 2 nails that equal 2. So this is really simple, and we start with that when we're just beginning to think of equating things mathematically. Let's look here on the left at this equation. On the left-hand side, we have 5, and then we have a bunch of other mathematical expressions, right? Up here we have 10 minus 5. 10 minus 5 is 5, so that is equal to 5, so that is an equation. 3 plus 2 is 5, and that is an equation. 15 divided by 3 is 5, so that too is equal to 5. And negative 3 plus 8 is also 5. So I'm saying that any one of these is an equation, right? 5 equals 3.2. This is an equation. Now, there's no real point to be writing it like this if we know the answer to this side here, to the right-hand side. But eventually what we want to get to, right, are these types of equations where we have a variable like x and we can do something with it. But it's important first to understand what an equation is, that we're looking at a mathematical expression that has an equal sign in the middle. And that equal sign means that this side here on the left is equal exactly to the side on the right. So here are some examples for things that may be equations or may not. For instance, we have here 3 equals 6 divided by 2. Well, 6 divided by 2 is equal to 3, right? So this is an equation, yes. What about this? 7 is less than 3 plus 5. Well, 3 plus 5 is 8, and 7 is less than 8. But this is not an equation because we do not have an equality here, right? We have a true statement, but it is not an equality. So no, this is not an equation. What about this? Here we have an expression, 3 plus 6. 3 plus 6 is 9, but we don't have an equality here either. So not an equation. So these are just examples to remind you that not every mathematical expression is an equation. Okay, so with this sort of very basic introduction, we're going to look further at what happens with variables and then at the various properties of equalities. So our next step will look at equations with variables. Again, a reminder of what a variable is. X here is a variable. It's a number that can change, right? It's not a specific number. It's a number that we might have to solve for. We have to look for it. It's an unknown, right? X is unknown. Okay. Now, in this first example here, 5 equals x, we can ask the question, what is x? Because we know this is an equality. We know that the left has to be equal exactly to the right. So x has to be 5, right? X is 5. Or in other words, x equals 5. So this is pretty simple, right? It's obvious. Well, What about this following example? 5 equals x plus 2. Here too we can ask, what is x? If x is 3, we'll get the right answer, right? But we can say, oh, x is 7. X is a variable. It can be any number. That's true. But if we want this equality to hold, we have to make sure that x plus 2 is exactly 5. And we know that if x is 3, then we'll get the right result, right? We'll say 3 plus 2 is equal to 5. So x is 5. So these are very, very simple examples, but they highlight the most important thing about equations with variables. And that is that once you put that equality sign in there, the variable is no longer free to be whatever number we want it to be. It has to be a number that solves this equality, that makes sure that this equality is true. So the equality has to hold true in order for x to solve it. And so once we put in that equality, now we are able to say exactly what x is. So both of these examples were really quite simple. In the first one, we saw on the page exactly what x was. And in the second one, it was pretty easy to guess that x equaling 3 would solve this equality. But sometimes equations can be a little bit more complicated or more confusing. And then we need a set of rules that'll help us solve the equations or the equalities. And to do that, we have a set of properties of equalities that are all listed here. The first one is the addition property of equality, and that's going to be the one we will look at first. But we also have subtraction property of equality, we have multiplication property of equality, and division property of equality. We actually have more properties, but these will suffice at this point. So let's look at the addition property of equality, and I'm going to write down a very simple equation that doesn't even use numbers. It uses letters as variables. Okay, this equation says A equals B. So if A is actually 3 apples, then B will be 3, right? If A is 17, B is 17. If B is 69, A will be 69 as well. Both sides of this equation have to be equal. So A is exactly B. A is B, right? Now, this again is a simple equality, but we can show with it what the addition property of the equality is. I am going to add to both sides of this equation a number. For instance, I will add the number 1 to each side of this equation. Okay, I have on the left-hand side A plus 1, right? I added 1. And on the right-hand side, I have B plus 1. Now, because A is B and A equals B, we also know that A plus 1 equals B plus 1, right? If we had 3 apples and we added a fourth, we added 1 more apple, we have 4 apples on the left. If we add another apple to the right, we have 4 apples on the right as well. So this is a really important property, and that is if I want to add something to an equality, I have to add the same thing to both sides of the equality. I can also add 17, right? I can say A equals B, and now I'm going to add 17 to both sides. So plus 17 and plus 17. And as a result, I get A plus 17 equals B plus 17, right? Again, if it was, say, candles, I've added 17 candles on the left and 17 candles on the right. So what used to be equal is still equal because it was augmented or it was increased by the same amount. We can also add a variable, okay? We'll do that here. Again, we have A equals B. And now I'm going to say, oh, I want to add something, but I'm not quite sure yet what. I'm going to call it X. I'm going to add X to this side, and I'm going to add X to this side so that both sides stay equal. So I have A plus X on the left, and I have B plus X on the right, and they are equal because A was equal to B, right? And I added to both sides the same amount. So I increased them by the same amount. And this is the addition property of equality, where I've added the same thing to both sides of this equation. Now, adding has a reverse action, right? Which is subtraction. And really, we know that subtraction is very similar to addition. Instead of giving, we take. Instead of adding, we take away. And so we can do the exact same thing we did with the addition. Again, if we have A equals B, so we have, say, on the left-hand side, 3 apples. On the right-hand side, we'll have 3 apples as well. Now let's say, oh, we're taking away 1 apple from both sides. So -1 on the left and -1 on the right. And we have A minus 1 equals B minus 1, right? Because again, these two sides started out equal and we subtracted from them the same amount. So we took away the same amount. And we can do the same thing with a variable. Let's subtract the variable x again, and we won't know a priori beforehand what x is, but we can, if we are careful to subtract the same amount from both sides of the equality, they stay equal. So let's subtract x from this side and an x from that side. Put the line underneath, and we have a minus x here equals b minus x. So that is the subtraction property of equality, and it's very similar to the addition property, and they both make a lot of sense. If both sides were equal and we either added to both sides or subtracted from both sides the same amount, we remain with an equality. It's not the same amount anymore, but both sides have the same amount. So we went from A to A minus 1, and we went from B to B minus 1, and since A is equal to B, A minus 1 is equal to B minus 1. Before going on to the next two properties, I'd like to give a concrete example. For instance, we have the equation 5 equals 7 minus 2. We know this is correct, right? 7 minus 2 is just 5. So indeed, 5 is equal to 7 minus 2. This is correct. Now, let's subtract 3 from both sides. Okay, so we write minus 3 here and minus 3 here. We put a line underneath, and we get on the left-hand side 5 minus 3, and on the right-hand side we have 7 minus 2 minus 3. So let's work out both sides. 5 minus 3, what is that going to be? That's just 2, right? And 7 minus 2 is 5, minus 3 is 2. So we end up with 2 equals 2. And that indeed is correct. So again, these are simple examples, but they're a reminder that you're allowed to subtract and add numbers or even variables from equations as long as you're careful to subtract and add from both sides. So the next property we'll look at is the multiplication property of inequalities. And this again is similar, and we will use our same basic example of A equals B. And again, if we have A equals 3 apples, then B will be 3 apples. And if A equals 7, then B equals 7. So they're both the same because they have to be equal. And now what we're going to say is, let's multiply this equality. Okay, we would like to multiply it, say, by 2. And we can do that as long as we multiply both sides by the same number, with one single caveat that I'll bring up a little bit later. So we say we multiply by 2, both sides. So now we have on the left-hand side, we have 2 times a, and on the right-hand side, we have 2 times b, and they are equal. Because if a equals b, then twice a should equal twice b. So if we had a equals 3 apples, now we have 6 apples on the left. But since b was also 3 apples, we have 6 on the right as well. So again, we have the exact same behavior. We're allowed to multiply, but we have to make sure that we're multiplying both sides of the equality by the same number. Can we multiply by a variable? Well, yes, of course we can. And we can do that right here. A equals b. Now let's multiply by the variable, say, y. So now we have times y, and I'm using y instead of x because I don't want you to get confused with the multiplication symbol. So now we have y times a equals y times b. Okay, now this rule is a little bit more complicated than the addition and subtraction properties. And the reason for that is that we have to make one requirement on the thing we're multiplying with. And that is, we can't multiply by 0. So no multiplication by 0. Why is that? Well, say we had an equality that we weren't sure was correct or that we had to solve for. For instance, say we had the equality 3 equals 5 minus x. Okay, so now we know, even by just guessing, that x is 2, right? If x is 2, then 5 minus 2 equals 3, and this equality holds. Now, what happens if I multiply both sides by 0? So if we multiply this side by 0 and this side by 0, what do we get? We get 0, and I'll put a little dot in there, times 3 equals 0. And now on the other side, we have 5 minus x, and I'll leave that in parentheses. Now, 0 times anything, or any number, is exactly 0, right? So we get 0 equals 0. And when we get 0 equals 0 is an equality, and it is true. However, it tells us nothing about x, right? We know that x can only be 2 to solve this, right? X equals 2. But when we multiply by 0, we basically lose that information. So this multiplication property of the equality holds only for non-zero multiplication. And that's a very important rule for this property of equalities. So we're finally at our fourth and final property of equalities, and that's the division, the inverse of multiplication. And by now, you probably know what I'm going to do. I have A equals B, and I'm going to say, well, I would like to divide this equality. Can I do that? And the answer is yes. Again, let's imagine we have 3 apples and we have 3 kids, and on the right-hand side we have 3, and on the left-hand side we have 3. And so if we divide the 3 apples on the right among 3 kids, or we divide the 3 apples on the left among 3 kids, we'll get the same result, right? And the same thing goes for other numbers and other objects. So we are allowed to divide, but we have to make sure that we are dividing both sides of the equality by the same number. So Usually when we divide by a number, in the case of an equation, we will use the fraction symbol to show that. I will do both so that it's clear. So first of all, let's divide by 3 on this side and on the right-hand side. So we get A divide by 3 equals B divide by 3, right? Again, we divided both sides by the same number, so they are equal. Now again, usually what we like to do is what we'll do is when we divide by 3, both sides, we'll just put a little line under the A and a little line under the B so that they turn into fractions, where the denominator is the number we divided by. Because we know that, for instance, 5 divided by 3 is just 5/3, right? So this is usually the way we'll write out division in an equation, but we can always go between these two examples. And again, we can divide if we want by a variable. Again, when we divide by a variable, we have to make sure that we're not dividing by 0, because dividing by 0 is a big no-no in math, and you've learned that in general, but that remains the rule. So if we want to divide A equals B by some variable x, we can write it as A divided by x equals B divided by x, or more simply, A over x as a fraction equals B over x as a fraction. So these are the 4 properties of equality, and they take quite a bit of practice to really kind of get used to them, and reminders that these actions, these properties, when we put them in action, are legal. And what we'll do in the next couple of videos is exactly that. We're going to look at quite a few examples where we use these properties in a very clear way so that they become basically second nature to you when you see an equation. So thank you for joining me again for another video. Include in the comments below any specific questions you have. If you're new to my channel, please subscribe, and I'll see you in the next video with examples of these equations and their properties.